that otherwise. If you look at a organic LED display and you compare it to, for example, a plasma TV or an LCD display, you will, without knowing, you will probably 9 times out of 10 pick the OLED display as being the one that you actually like the look of. There's something about the saturation and the colour that's very, very appealing for these materials. They're DC, so you don't have to plug them into the mains. You can run them off batteries, so 3 or 6 volts is typical there. And they have the potential to be very energy efficient. We'll see some numbers a bit later about energy efficiency. These are improving all the time. And I think quite importantly there, you can see the red, green, blue spectrum. The OLEDs are actually broadband emitters. They're quite broad in their emission wavelengths that they give off, which can have some really good advantages, unlike, again, inorganic LEDs, which have a very narrow peak. And of course you can use that to either combine them in clever ways to make white light, for example, or you can actually have OLEDs which emit white light themselves. So how do they work? Well, as I said, what you do really in very simple ways, you take a glass or flexible substrate, you put something called ITO on usually, which is indium tin oxide. That's a transparent conducting oxide. It means that you can put electricity in but still see through it, because you've actually got to get the light out. Then there's some organic layers and a metal cathode, usually aluminium for example, and you apply your voltage across and you form what's called a PN junction, and you get light emitting. Now, if you really want to get complicated, you can have all sorts of layers, and you know, if you want efficient emission, if you want certain properties, if you want certain lifetimes, then you can build these layers up, and you can see on the right hand side there are all sorts of different layers in there. Actually, if you don't want that and you want a really snappy device that's relatively easy to make, it doesn't have to last that long, it doesn't have to be that bright, and doesn't have to be that efficient. You don't have to worry about that, and you can make them relatively simply in the laboratory. I've got a note on there that you'll have read now. I always like to think of these things because otherwise you can't get an idea of the scale. The total stack that you can see there of the organic material is built onto a piece of glass. You probably can't see it that well, but this is about 0.7 millimeters thick. If that layer was scaled up to 1 millimeter, so about the same thickness as this piece of glass, then this substrate would actually be 1.5 meters tall. So it's an incredibly thin layer. And that actually brings interesting properties, but also problems, of course, as well. So if